Hi, and thank you for joining us for the latest International Symposium on Human Identifications video series. Today we're with Nicole Novroski. Did I get that right, Nicole?
Yeah, that's
okay,
good.
Great. She's a forensic geneticist and she's here to talk with us today. Why don't you tell us a little bit about yourself and your work?
Sure. So, like you mentioned, I'm Dr. Nicole Novroski. I am an assistant professor at the University of Toronto, and I specialize in forensic genetics. Within my role as an assistant professor, I have both a research lab where I have a growing team of young scientists, and then I also teach within the forensic science program at the Mississauga campus.
Tell us a little bit more about what it's like to be a forensic anthropology professor. What does that entail?
So just to clarify, I am a forensic geneticist, but our forensic science program is housed within the Department of Anthropology simply because all of our directors have inherently been forensic anthropologists. And so we've been kind of stuck in anthropology for all of intents and purposes at the administrative level. But essentially what I have developed since I joined UTM's faculty is a forensic science research program that specializes in forensic biology and forensic genetics. So I am the head of my own lab that focuses on forensic genetics research initiatives that are really trying to push the envelope further. I also am the primary faculty member for the Forensic Biology Specialist program for our undergraduate program. And within that capacity, I have developed a series of new courses, or essentially I've rebuilt the curriculum so that undergraduates going through the forensic bio stream really can immerse themselves in a strong foundational understanding in forensic biology so that they're better prepared for the future when they move on to other things after their undergraduate degree.
Okay, so just a little bit busy, it sounds like.
Sometimes.
How did you get interested in the field?
So ironically, I'm an alum of the UTM Forensic Science program. I grew up in Canada. I did attend the University of Toronto for my undergraduate degree, and I fell in love with forensics in 11th grade when I wrote a paper on DNA fingerprinting and learned about Alec Jeffreys and everything that kind of sparked their creation or the initiation of the forensic genetics subdiscipline back in the mid-1980s. Oh my goodness, time is flying by. However, I joined the UTM Forensic Science program not really knowing what it was that I was truly passionate about, but of course, holding true, fell in love with biology and continued in that discipline for that undergraduate program. Once I left there, I wasn't really sure what I wanted to do, but I ended up working in an RCMP detachment, which then kind of re-sparked that I need to be a forensic scientist. And then I took my academic journey to the United States, where I did my master's degree, had the opportunity to work at the OCME in New York City, and then spent my doctoral time at the University of North Texas Center for Human Identification. And that's when I really excelled and pushed the limits of my understanding of forensic genetics and really explored a variety of new technologies, chemistries, and truly developed a strong passion for forensic genetics in terms of driving my career forward.
That's quite the career. What have you seen? How have things changed since you started? What have you seen?
Everything has changed in theory. So, I mean, the underlying foundation of forensic biology, DNA extraction, quant amplification, generating that DNA profile, all of that remains pretty standard and has been a standard form of practice now for a couple of decades. However, what we're seeing is this implementation of new technologies and new chemistries that are really changing the questions that we're able to answer. These technologies and chemistries push our limits of understanding on the practices that we already knew. We're going down into these super low levels of sensitivity and specificity in terms of what we're able to capture from any given biological sample. We really have immensely changed our capabilities as forensic practitioners in terms of the questions we can answer and the sample types that we can process. what I find particularly interesting is these new technologies really allow for the generation of information from the poorest quality samples or the lowest level amounts of DNA. And not always can you answer everything that you're asking, but we have changed our potential capability of answering questions. If you think about something like DNA mixtures, when, a decade ago or 15, 20 years ago, it's very, very hard to deconvolve even, two-person mixtures depending on the ratio of each person in that DNA mixture. Now, using probabilistic genotyping and other advanced software, we can deconvolve 5, 6-person mixtures with some inherent probability for our predictions or our assumptions. And that is truly remarkable just in terms of how far we've come and how much we've been able to grow as a field and essentially solve more crime as a result of our improved techniques and methodologies.
It is amazing how far it's come. Is there anything that's been the most surprising to you?
So I love learning and I love watching things change and I love evolving with the times. So I think as we continue to look at how things are improving, I am just fascinated at our increased capabilities. I don't joke about it, but you think about that era of serial killers in the 70s and 80s, and that was all pre-DNA. And since DNA typing has come online and our increased use of databases, we've really decreased, in theory, the number of violent serial offenders, or we're better able to gather all of the evidence and really process those investigations and make connections between those investigations. And so for all those true crime lovers that are sitting at home, I'm like, these are old cases because DNA power is so prevalent now, and we can really exploit our forensic technologies to help our society, our community. So I am always excited and I'm always surprised at how much good we can do with the techniques that we're bringing online and how many cold cases we're now able to solve because of our improved capabilities, like genetic genealogy and all of these cold cases that are using phenotyping or some kind of ancestry information to kind of piece together those missing or unanswered questions from the past. Those always just bring such a smile to my face that closure has been achieved for those families, that we can finally close those cases that have been outstanding for 10, 20, 30 or more years. So that's always a remarkable and a big feat that I think that the community is giving back to society.
Absolutely. Seeing all of those cold cases that have been solved just in recent years, recent months even, it's remarkable. How about challenges? What challenges are you facing now? What do you think will happen as we go forward?
So as a young researcher, my challenges are always a little bit different. I am growing my lab and I have students that want to go into a whole bunch of different directions, and I'm still learning myself. So as a young professional in the field, I'm really getting my grasp on what my skill sets are, where my knowledge is, and how much I can still learn from my mentors and the experts in the field. And I think one of the biggest limitations is really deciding what direction do you want to go into. So there are so many different avenues or areas of research in forensic genetics, and you can't do it all. But I do have students that want to do it all. And so one of my biggest hurdles right now is really trying to figure out how much I can achieve in my career in my next 1, 3, 5 years, and what that's going to look like and how that is inherently going to contribute to the field of forensic genetics. But we'll see. I mean, every day is an adventure. If the pandemic has taught us nothing else, it's to live a little bit more in the moment and to go with the flow, which I think is very hard for forensic scientists and a lot of individuals who, I'm a planner, I like to be organized, and I like to know what my next year is looking like, and I've really had to take a step back and pivot quite a bit. But I have, a lot of amazing colleagues, and I have a strong team back at the University of Toronto that are really trying to, push our research program forward and keep answering what questions we can.
Yeah, you work with an amazing group of women. Can you talk more about your lab and what everyone is doing?
Sure.
Yeah.
So right now within my lab, I have 3 doctoral students, 2 master's students, and anywhere between 4 and 6 undergraduate students working on their individual projects. Everybody's doing something a little bit different. So within our doctoral program, I have a student that's very interested in human pigmentation, so thinking about those externally visible characteristics, hair color, eye color, freckling, etc. And her goal really is to better understand some of the genetic influences that contribute to the visible phenotype. And I know there's a ton of work that has been done in forensics with regard to that, so we are going to try and answer some new questions without giving too much away. I also have another student that's taking me in a rather novel direction. She's very, very interested in the mitochondrial genome, and so looking at the evolution of mitochondrial DNA use in forensics, we've migrated away from using only the hypervariable regions 1 and 2, which were our standard practice, to make human identity comparisons for kinship and missing persons, etc., to looking at the entire mitochondrial genome. And so in her exploration of the mitochondrial genome and better understanding how you can use it for human ID, we're also extending into disease and looking at the mitochondrial genome within a psychiatric disease lens. And so some new stuff there for me, a little bit outside of forensics, but working with postmortem samples, so really still coming full circle and tying it back into the medical legal system. And then obviously a handful of other smaller scale projects. The master's students are looking at secondary transfer, some population studies, and a variety of more simplistic projects at the undergraduate level, answering basic questions about serology and comparing different extraction kits, etc. Easy projects that have a quick turnaround in terms of a 1 to 2 year project timeline, but still hands-on, engaging, hopefully going to lead to a small publication or presentation for them, and providing them the opportunity to get into the lab and really understand both the strengths and limitations of forensic biology.
That's so fascinating. And since you're working with students on a day-to-day basis, would you have advice for anyone who's interested in entering the field or studying?
Of course. So I look at my own journey, which is quite, it's been very lucrative, but it has involved a lot of risk assessment. I always encourage students to determine what is it that is your priority. Is your priority to stay close to home with family? And if so, that might dictate what job opportunities are available for you. Is your priority to seek that cutting edge internship or placement with, somebody that you idolize in the field? And if so, how does that work for you? How can you make that work? So my journey and experience has always been to go after that goal or that adventure, or to try and get into that lab or work with that individual. And it's come at that kind of compromise or consequence of giving up some of the more safer choices had I stayed back home. And I always just encourage students, wherever their path is going to take them, that it is inherently their decision to make. What is your priority? What is it that you want out of life? This is your one chance to go after it, and don't hold back. If it's something that you really want, everything else will kind of figure itself out, or that's been my experience. And sometimes it's hard. I've lived in several different places where I showed up and didn't know a single person, but humans are very adaptable. We figure it out, and if you're passionate and you want to be there, that's going to come through in your work. That will open other doors, and you're kind of driving your own success. So always just chase the dream. And I know it's so cheesy, everybody, go after your dream, but at the end of the day, it's your career, it's your life. You gotta hustle, and I hope that that's what my students take away from working with me. I hope that when students are sitting in my lecture or they're seeing something recorded of me, that they can be like, well, what is it that I actually want to do? And that drives their decision forward, because everybody's path is going to be different. So really just go after it.
I think that's the best advice that you can give anybody, and hopefully we've all learned to be a little bit more adaptable over the last year or two,
Hopefully.
whether we wanted to or not.
Right?
How does STEM play a role?
So STEM being science, technology, engineering, math, I really, as a woman in STEM or as a female in STEM, I very much encourage young scholars to make the most of their academic experience, right? The STEM field is challenging. There's a lot of adversity at a variety of levels. It can be disparities in hiring, it can be disparities in opportunities for funding. There are so many challenges that can exist, but ultimately, I look at myself, I've been trained by some of the leading forensic scientists in this field. I consider myself very fortunate to work with colleagues like Dr. Bruce Bedoy, Dr. Michael Coble, Dr. Magda Boos, all of these really wonderful individuals who have crossed paths in my life that have really provided me with unique perspectives and different ways of approaching a problem and different ways of approaching the world, and feeding that back into the raw science that we're putting out into the community. Ultimately, forensic genetics is an applied discipline within science, and as an applied discipline, it is perceived by other scientists in perhaps a different lens. But when I think about my contributions to STEM, I think about the fact that the work that I'm doing, the publications that my team produces or that I've been a part of, are immediately contributing back into society. They're immediately making an impact in the world that we're living in, and they're potentially going to influence what's happening in the courtroom either tomorrow or next week or next year or in the next 5 years. And I think that is an incredible win. When I hope to look back on my life and say, like, you know, I didn't cure cancer, but I definitely made an impact in the world, and I did, you know, influence lives and really change the direction or the course of some careers in a positive and upward direction. And so that is hopefully my contribution to STEM. And ultimately, I just want to inspire young people to pursue a career in science, to pursue a career in STEM, because it is possible. You can go off to do great things, and you can leave an impact at both a local and a large scale capacity.
Clearly that is a win, and obviously one of the more rewarding aspects of your work.
Hopefully.
Right, exactly. What are some other things that are both rewarding and frustrating, just to help people a little bit understand what you're working on?
So teaching definitely makes me nervous. I love teaching. I love sharing my passion for forensic genetics. I love students coming to me with questions that I can't answer, that challenge me to consider new approaches to a problem, and that just inspire me to work a little bit harder and learn a little bit more. So having worked with some really fantastic individuals in the field, I've always been humbled by the smarter person in the room, or somebody always being able to ask me a question that I won't know the answer to, that they may already know the answer to. And that is both, you know, acknowledging my weakness or my limitation in my own knowledge, but challenging me to become a better scientist, to become a better professor, to become a better mentor, to become a better colleague. I think what is maybe the biggest challenge or limitation right now has been navigating a young team through this pandemic. So bringing students into a graduate program during the pandemic has been a bit of a hurdle because there's no in-lab experience right now, and expectations in terms of what their responsibilities are have been a little bit unclear. But I'm hopeful, and I'm really looking forward to this upcoming year and seeing that transition back into the classroom, back to the bench, where students are going to gain more hands-on experience. They're going to be able to really excel in their own way, and then that will, I hope, change our dynamic a little bit in terms of inspiring them to ask deeper questions and really push the envelope further. And hopefully we're back here next year at ISHE, and we have a little bit more science to present in terms of posters and presentations, and seeing some of the things that we're working on right now kind of materialize into successful products. So I think, yeah, it's been a time, right? I think we can all say that since we were sitting here in 2019.
Absolutely.
A lot of change.
No, it's wonderful to have everybody here, but we're just sort of getting back to that after being remote for a full year. So,
and there have been some labs that seem to have been uninterrupted, and there's a little bit of envy there, but Canada specifically has approached the pandemic in a very unique way compared to a lot of countries. So we have been in a shutdown state for quite some time, but the power of Zoom and the power of making those remote and virtual connections, I am thankful for, and we will just continue to be resilient and persevere and adapt to this change, right?
Right, we keep finding a way. Well, what's next for you? What does the future hold?
Always hard to say, always hard to say. I am always, and will probably always be, passionate about DNA mixtures. So a few projects that circle around DNA mixture interpretation and really exploring new markers in the genome. That's not incredibly new in terms of my research background, but it is something that we can always take a step further. Moreover, just growing the lab and bringing on additional equipment and really fostering the collaboration. So at the University of Toronto, I've really had the luxury to work with some wonderful external agencies, so the local crime laboratories that are in Canada, working with some fantastic biotech partners, and then building internal collaborations with our Faculty of Medicine, and there's a big mitochondrial DNA group at the downtown campus at the University of Toronto that we're collaborating with for that mitochondrial disease project. And I've only been in this position 3 years, coming straight from the Center for Human ID, and I look back over my 3 years at how transformative the experience has been, and how my collaborations and the number of colleagues I've acquired has just exponentially changed. And I can only hope that my next 3 to 5 years continue to be as prolific as my first 3 years have been in this role, and that we really continue to see a great team mentality. We continue to see publications that are worthwhile, and that we're really addressing the needs of the forensic community while still providing an educational experience for our incoming students that will hopefully impact them to become better forensic scientists in the future. Because ultimately they come through, as everybody who's done an undergrad program knows, you can go through your 4 years and be like, I still have no idea what I want to do. But what I have found to be quite remarkable is that I've had students enter my third year class, and by the time they leave at the end of their fourth year, their senior year, they're like, spending time with you and taking your courses has really inspired me to want to pursue this field. And those comments are truly significant. Like, I have impacted those lives to pursue a field in science, or to pursue a career in forensic science. And if that's the only difference I make, then that's still a huge contribution to the field, I hope. So keeping on that train of positive influence and contribution is hopefully what the future will bring. But like I said, one day at a time, and I'm just here along for the ride and going with making the impacts where I can, I suppose. But
Well, I know we can't wait to see what you and your students do going forward, definitely.
yes, we will be back next year in full swing, hopefully.
That's
so
good.
yes.
And have you been to Ishi in the past?
Yes, so Ishi is by far my favorite conference, just to keep that between us. I've been attending Ishi now since 2014, I believe was my first year, and I've only missed a couple due to other prior commitments, but Tara, Sue, everybody is just so, Carol, everybody is so fantastic. I haven't seen Anne yet, but hopefully I'll see her. Everybody has just been so supportive, and the conference is so well put together, and all of the colleagues that I get to see here on an annual basis, and the venues are always fantastic. I'm so thankful every time that I get to come and just reconnect and visit with everybody and see all of the great work that's happening around the world, because really this is one of the few international conferences that focuses specifically on forensic DNA, and it always brings the best of the best to the program, to the table, and I absolutely love being able to come and listen and learn, but also contribute to this great conference. So glad to be back, looking forward to future years, and continually thankful for my experience and connections that I've been able to make through attending the annual Ishi conference. So.
Well, thank you for sharing that. I know we are so happy to have you. And now that we've spoken, we'll probably be reaching back out to you multiple times to do that again and see how things are going as we progress.
Perfect.
Well, thank you so much for taking time to come in. We really appreciate it.
Thank you so much for having me, and thanks to Carol and everybody that makes this conference happen. So thank you.
Have a great conference this year.
You too.
Thanks.